Okay, this is a review for the Module 5 test. Okay, I'm going to go through all of these questions. You guys do not have this file right here, this paper. You guys have a different review, but this one more closely resembles what the test will actually look like. Okay, so I will be sending you guys this one so you guys can use it as you watch the video to review. Okay, so here we go. Number one. Identify the graph of the function as even, odd, or neither, and explain how you know. So I'm going to start this one by defining what even functions and odd functions look like. So let's start with even functions. An even function, if you're doing it algebraically, meaning not on the graph, what you do is you substitute in negative x for x. So you find f of negative x. And if you get back the exact same original function, then it's called even. Okay. Odd functions, if you substitute in negative x and you get back the opposite of the original function, then it's called odd. And neither, we say neither when it's neither odd or even. Okay. Now if it's not algebraic, if it's graphically, then you can tell even functions, this one's odd. That's algebraically. Graphically, you can tell if it's even by looking at the graph and seeing if it's symmetrical. It has to be symmetrical about the y-axis, meaning that the y-axis is the line of reflection, which is the case in this problem right here. Okay, if you guys see the y-axis right here, this is the y-axis. The graph is symmetrical about the y-axis, right? It's a perfect reflection right through there. Okay. Odd functions are also symmetrical, but not about the y-axis. They're what we call symmetrical about the origin. So when you look at it, it doesn't actually look symmetrical. Okay, what we mean by symmetrical about the origin is that if there's a point, for example, 1, 1. That's a bad example because it's the same number back twice. Let's change that to, if there's a point, for example, 1, 7 that exists on one side of the graph, then the point -1, -7 exists on the graph as well. And the point 2, 3, the point -2, -3 exists on the graph as well. Okay, so it's symmetrical about the origin, where you can just reflect over the origin. You're jumping over the origin to its exact opposite side. So in this case, this one is obviously even. We can see that it's even because it's symmetrical about the y-axis. Okay, we can't tell algebraically. We cannot tell algebraically because I don't have the function of this. All I have is the graph of it. But I can see from the graph that it is symmetrical about the y-axis. Okay, what would an odd one look like? Let me just draw a quick example of what an odd one would look like. Here's my x-axis and my y-axis. And an odd function would go something like this. From the origin, it goes like that. And then it would be the exact opposite on the other side. I'm going to try to draw it. Something like that. Okay, that's odd because it's the exact opposite over the origin instead of over the y-axis. Okay, let's move on to number 2. It says here, the following relation is a function. Write the inverse relation as ordered pairs. Is the inverse relation a function? Why or why not? There's a little typo right here. It should say function, not function. Why or why not? So let's first check. It says write the inverse relation as ordered pairs. Let's start by doing that. Okay, write the inverse relation as ordered pairs. That's actually really simple. All of you guys should be able to handle this question. Okay, what it means by writing the inverse relation? Remember, the inverse is always flipped. You reverse the x and the y values. So if the first point is -4, -2 right here, then the inverse will be -2, -4. And so on. I could do that for all of the points here. So the next point is going to be -2, -1. So negative. And the next one is going to be 7, 0. The next one is going to be -4, 1. And then the final one is 9, 4. There, done with that part. The second question is the inverse relation a function? Why or why not? Okay, so let's recall back when we started talking about functions. I told you guys that a function is always going to be one-to-one, meaning for each input there's exactly one output, or it could be many-to-one. Meaning that many different inputs can go to the same output, and that's okay. Okay, so remember we looked at it like this. There was numbers here, input and output values. I'm just going to make up some numbers here: 2, 3, 4, and 5, 6, 7, 8, 9, for example. Let's erase the 9 right there. Let's just leave it as 5, 6, 7, 8. Let's just leave it as 5, 6, 7. It makes it easier, faster. So one-to-one would mean that each one of these input values goes to one output value. And that's okay. That's a function. Okay? Many-to-one. Okay, my alarm just went off. Many-to-one would mean that various many different inputs go to the same output. Okay, so what that would look like, let me erase this last one and erase the 7 here. What that would look like is this: 2 goes to 5, 3 goes to 6, but 4 also goes to 6. So many different outputs, in this case only 2, go to the same output, which is 6. So 2 goes to 5, 3 goes to 6, 4 goes to 6. 3 and 4 both go to the same output value, so this is called many-to-one. This is okay. This is a function. Okay. What would not be okay is what we call one-to-many, which means that one input value goes to many different output values. Let's show an example of that. How about I have inputs 3 and 4, and my outputs are 7, 8, and 9. 3 goes to 7, 4 goes to 8, and let's say 4 also goes to 9. This is not a function because the input 4 goes to many different outputs. Okay, so that's how you check. So in this case, -2 goes to 4, then -2 goes to -1. Fix this -2, it's annoying me. -2 goes to -4, and then -2 goes to -1. Right away, right there, I can tell that this is not going to be a function because the input -2 is going to many different outputs. It's going to -4, and it's also going to -1, so it's not going to work. So this one is not a function. And the reason why is because it is one-to-many. It's a relation, but it's not a function. One input goes to many different outputs. Okay, let's move on to number 3. It says find the inverse function for this function right here. F of x equals -7 over 9x plus 6. Okay, so remember this, you do not pronounce f to the -1 power. That's incorrect. It's f inverse. Okay, so we're looking for the inverse of this function right here. Step 1, always replace f of x with y so that you can work with it a little easier. Okay. Next, what I'm going to do is solve for x. I want to isolate the x all by itself. So what I'm going to do is I'm going to subtract 6 first.
Daddy?
Yes?
What are you doing?
So on the left side, I'm going to have y minus 6 equal to -7 over 9x. Because the 6 and the -6 are going to cancel out. Next, I need to get rid of the -7 over 9. I'm going to use the reciprocal of that fraction, which is -9 over 7. Why am I using a negative? Because I want the negative to go away. Negative times negative will make it positive. And so all I have left is x. Now I need to multiply on the left side as well times -9 over 7. And so I'm going to get -9 over 7y plus, because it's -9 over 7 times -6. 6 times 9, 72. Wait, not 72. Let's undo that. 6 times 9 is not 72. 6 times 9 is 54. Somebody's not thinking straight. Over 7. Thank you, Ciel. That was my son correcting me. -9 over 7y plus 54 over 7 equals x. And now what you do is you reverse the x and the y, right? So you're going to have negative 9 over 7x plus 54 over 7 equals y. Now when we write it, we don't write y, right? We write f inverse. So my final answer will be f inverse of x is equal to negative 9 over 7x plus 54 over 7. And 7 doesn't go into 54, so we're just going to leave it like that. That is your final answer. So remember the basic steps. Change f of x to y. Isolate the x, so solve for x. Reverse the x and the y to have the inverse. And then change y back to f inverse. And there's your inverse. And how do we check that this is actually correct? Actually, let's do the check right now. Let me check that this is actually correct. So if you recall...
Daddy, let me try that.
You want to try to erase? Okay, that's enough. Thank you. Now, if you recall, in order to check that the functions are, it's actually the inverse, what you do is you do a composition of the two functions. So you substitute f inverse into f of x, or f of x into f inverse. Either way, you should get x. Okay, so let's try right now. I am going to substitute f inverse into f of x. So what I'm going to get is, let's say f of x is negative 7 over 9 plus 6. So in place of x, what you do is you substitute in negative 9 over 7x plus 54 over 7. 54 over 7. Now this mess over here, I'm just going to call it g of x to make my life easier. So let's call it g of x. And negative 7 over 9 times negative 9 over 7x plus 54 over 7 plus 6. Just go ahead and distribute. Negative 7 over 9 times negative 9 over 7 is 1. So 1x, or just x. Negative 7 over 9 plus times positive 54 over 7. Negative times positive is going to be negative. The 7s are going to cancel out. So it's 54 over 9. 54 divided by 9 is 6. And then there's a 6 outside at the end. The positive 6 and the negative 6 will cancel, which leaves me with g of x is equal to x, which means that my answer is correct. Okay, number 4 says, find the inverse function for the function. So once again, it's very similar to number 3. But then it says graph both on the same coordinate axis. Use 2 colors and label your graphs. Okay, so let's start by finding the inverse. Let's do the same thing we did in problem number 3. So f of x is equal to 2 over 5x minus 1. I'm going to change f of x to y. Let's use black. Y is equal to 2 over 5x minus 1. Then what I'm going to do is solve for x, meaning isolate it. So I'm going to add 1 here. So it's y plus 1 is equal to 2 over 5x. Then I'm going to get rid of the fraction by multiplying by the reciprocal. So 5 over 2 is the reciprocal on both sides. 5 over 2. Then I'm going to, the reciprocal and the fraction cancel, so that just leaves you with x. On the left side, you're going to have 5 over 2y plus 5 over 2 times 1 is 5 over 2. And finally, reverse the x and the y. So here's your final answer. Y equals, actually it's not the final answer, right? We still have to change it into f inverse. Y equals 5 over 2x plus 5 over 2. Okay, change it to f inverse, and here's your function. F inverse of x is equal to 5 over 2x plus 5 over 2. That's step 1, right? Find the inverse of the function. Next, it's asking me to graph both on the same coordinate axis. And it says use 2 colors and label your graphs. Okay, so let's use 2 colors. I'm going to use blue for this one, and I'm going to use red for this one. Okay, so we know which one's which. So 2 over 5x minus 1. If you forgot how to graph these, I'm graphing this one once again. Graphing this one. If you forgot how to graph these, remember, find the slope. It's a line, right? And find the y-intercept. Begin and move. The slope is 2 over 5. The y-intercept is -1. So using that information, I can graph it. Begin at -1, right? B, y-intercept, begin on the y-axis at -1. So right here is your first point. And the slope is 2 over 5, which means that from that point, you're going to go up 2 and to the right 5. So from this point, I'm going to go 1, 2, 1, 2, 3, 4, 5. Right here is where I should land. So I'm going to put a point right there. And then you connect those 2 points to make your line. That way and that way. That's that one. Okay. Now the inverse. The inverse is this one right here. So I'm going to use the same strategy to graph it. Find the slope, which is 5 over 2 in this case. And the y-intercept is also 5 over 2. I'm going to change it into a decimal so I could get a better estimate of what it actually is. So 5 over 2 is 2.5, right? 5 divided by 2. So I'm going to begin on the y-axis at 2.5, right about here between 2 and 3. And then the slope is 5 over 2, which means I'm going to go up 5 and to the right 2. So from this point, I need to go up 5. Now, make sure when you're counting right here, this is not 1, right? Up 1 means you have to go to the middle of the next 2 points. This is 1. And that's 2, and 3, and 4, and 5, and so on. And I ran out of graph space. So what I'm going to do instead is I'm going to go in the opposite direction so I could graph it, right? 5 over 2 is the same thing as -5 over -2. Right? Everybody agrees on that? So that means that I can go down and to the left instead. So I'm going to go down 5, 1, 2, 3, 4, 5, right in the middle between -2 and -3. And to the left 5, 1, 2, 3, 4, 5, right about here. Okay, so let's draw it right about there. And so you make your line. That doesn't seem right. Well, of course it isn't right. I counted wrong. I'm supposed to go down 5 to the left 2, not down 5 to the left 5. So let's start that again. Plug it at 2.5, start at 2.5 right here. And then you're going to go down 5, 1, 2, 3, 4, 5, and left 2, 1, 2. Right here is where I should end up. So I'm going to put a point right there. Connect the 2 dots. And that seems right. Okay. The other one did not seem right to me right away because it wasn't a perfect reflection, right? Your function and your inverse should always be a perfect reflection of each other about this line, right? Across this line, y equals x. This is always going to be the line of reflection for two functions that are inverses of each other, okay? So you can see that right here. If I flip the blue line across this line, it's going to land on the red one, and vice versa. I could do the same thing to the red one. Okay, and actually that's a way for you to graph if you are stuck on trying to figure out what the inverse is algebraically. If you can graph the first line and then just use the fact that you know that it's a perfect reflection to just flip it over, you could graph the other line just using reflections. For example, this point right here, I want to jump it over this line, it's going to land right here. Okay, and so on every single one. If I do a perfect reflection of this point, it's going to land right there. Right? I could do that for every single point. And the point where the line, the original function, and y equals x intersect is the same point where the other line is also going to cross. They are all going to meet at this exact same point. Okay, let's move on to number 5 now. The graph of f is given, which is this graph. Kind of looks like an absolute value, but it might not be. But then it says graph g of x equals f of 2x on the same graph. Okay, so I'm supposed to graph this g of x, which is a transformation of f of x. Okay, so since I'm talking about transformations, what I'm going to start with is by writing the basic transformation function, right? If there's a function called f of x, g of x, which is a transformation of f of x, is determined by this. A times f of 1 over b x minus h plus k. Right? Does that bring it about to you guys? And my parameters are a, b, h, and k. However, we always write them like this, right? B first, then h, then a, then k. Boy hungry, ate kitty. And I separate the 4 into two pairs, b and h and a and k. Why do I separate them that way? Because b and h both affect the x, the input values, the x terms, the x values, okay? So affect the graph horizontally. Both of these x values. And both of these affect the y values, which means that they affect the graph vertically, right? And then we also know that b and a, both b and a, are always multiplied, and h and k are always either added or subtracted, right? Add or subtract, depending on what the sign of the number is. But b and a are always multiplied by the x values. H and k are always added or subtracted. Also, we know that b and a do reflections. They also do stretches and compressions. Reflections only if they're negative. So if b is negative, it's a reflection. If a is negative, it's a reflection. If b is bigger than 1, it's a stretch. If a is bigger than 1, it's a stretch. If b is less than 1, meaning a fraction, then it's a compression. If a is less than 1, like a fraction, then it's a compression. Okay? So let's look at what my function is, and let's compare it to this stuff right here. Because I need to figure out which parameter is this number right here. Is it an a, is it a b, an h, or a k? Is it related to one of those four? Okay? So I am going to cross out k right away, right? This number inside of the parentheses is inside of these parentheses, so it's definitely not k, which is outside of the parentheses. It's also not a for the same reason, right? It's inside of the parentheses, so it has to be in here somewhere, which means that it's not a. So it's not a, or it's not k. So that means that it's going to affect the x values of my graph, okay? It's going to have to affect the x values because it's either b or h. Now, how do I know if it's related to b or to h? I look at the way that my function is written, right? It's written like this: x minus h. H is always added or subtracted to x right here inside of these parentheses. That's not happening here. If you guys look at that, there's no x plus 2 or x minus 2 here. So it's not h either. It has to be related to b. It has to be related to b because if you can see that 1 over b is right in front of x, which is what the 2 is, okay? However, b is not 2. Don't say, oh, that's 2, so b equals 2. That is incorrect. Because if b was 2, then it would look like this: f of 1 over 2 x. Right? And that means b is 2 because b is in the denominator of this fraction where 1 is the numerator. Okay? So b is not 2. The question is, what is b then? If it says f of 2x, what is b? So what you're going to do is say, well, it has to look like this. It always looks like 1 over b. Compare that to the number that is actually there, which is 2. So all I'm doing is taking this 1 over b and making it equal to this, right? Those two things are equal to each other, and that will help me solve for b. I'm going to just quickly solve this proportion right here. Cross multiply. So 2b equals 1. And now you could see that if I divide by 2, that gives me the value of b. b is actually 1/2. Okay? Which I'm going to write right here. And we said before that h is not there, is not related. So the only thing that is affecting my graph here is b. It's 1/2. Okay? And we said, what does b do? It multiplies, right? Which values? The x values. So that's exactly what we're going to do in our graph right now. We're going to multiply the x values by 1/2 to get new x values. Are we doing anything to the y values? No, because a and k are not even there. Okay? So let's do that and we'll be done. That's basically the only step we're taking. So all I'm doing is looking at these points that they have given me, -4, -5. You know what? I'm going to write them on a table to make it clear so everybody can see. I'm taking those points that they gave me, -4, 5, 0, 1, 4, -3, and 6, 0. and I am changing them, I'm transforming them based on the information I just found, which is that b is equal to 1/2. Okay, since b is equal to 1/2, all I'm doing is multiplying every single one of the x values times 1/2. I am not doing anything to the y values. So -4 times 1/2. So you know what? Let me write the y values here because they're not going to change. Let's do the x values now. -4 times 1/2 is -2. Remember, when you're multiplying by 1/2, you're basically cutting it in half, right? That's what it means. 0 times 1/2 is still 0. 4 times 1/2 is 2. And 6 times 1/2 is 3. And those are your new points. And now I'm going to graph them. -2, 5. It's right there. 0, 1 stays at the exact same spot. 2, -3 right here. And 3, 0 right there. Connect those dots to make your graph. It goes like this, all the way down here, and then back up to that one. Okay? Now, does that make sense according to the information given? It does. If b is 1/2, that's a compression, right? A horizontal compression, not a vertical compression. That means horizontally, like an accordion, you're squishing this graph, and so it should look like that. Okay, number 6, determine algebraically whether f of x equals -x to the 4th plus x is even, odd, or neither. Show work and explain how you know. So I talked about this in problem number 1, and now we get to practice it algebraically. Okay, so algebraically, to check if something is even, if a function is even, odd, or neither, what you do is you replace x with -x, right? Let's go back to black. Replace x with -x. And so everywhere in your function you see an x, replace it with -x. Oops. Let's put empty parentheses for that one as well. There's two x's on this function, right? -x to the 4th plus x. So everywhere you see an x, in its place, put -x. And simplify it to check. If I get back the exact same function that I started with, then it's even. If I get back the exact opposite of the original function that I started with, then it's odd. If I get back neither one, the exact opposite or the exact same one, then it's neither. Okay, so let's simplify this. A simple mistake that people make here still all the time is they say, oh, negative times negative is positive, so it's x to the 4th. And so that would be incorrect, right? Remember your order of operations. Exponents first. Then multiply times the negative outside, because this negative is really -1. You're not supposed to multiply it until after you do the exponent. So what's -x to the 4th power? Well, negative times negative times negative times negative is going to end up being positive x to the 4th power. Now you multiply times the -1 that is outside, and so it ends up becoming -x to the 4th, which is exactly what we started with. But then you go to the next one, plus -x, that is going to be a negative, so it's going to be -x. And so you compare that to your original function and check, is it the exact same thing I started with? Is this the exact same thing as this? And your answer is obviously no, right? Because it should be +x instead of -x. So that means it's not even. Okay, is it the exact opposite of what we started with? Now, what would I mean by the exact opposite? If I have a function that is -x to the 4th plus x, the opposite is +x to the 4th minus x, right? That would be the exact opposite. So is this one the exact opposite of that one? Once again, the answer is no. The x and the -x are opposites, but the -x to the 4th and the -x to the 4th here are exactly the same. So no, not opposites either. Therefore, since they're not the exact same function and they're not opposites, this is neither. Neither. Okay, how do you know? How do we explain this in easy, fast way to understand? So this is what you write. You say f of -x does not equal f of x. What does that mean? If I replace x with -x, I don't get back the same function. That means that it's not even. Not even. And also, f of -x does not equal negative f of x. Meaning that when I replaced x with -x, I didn't get back the exact opposite. So not odd. that's basically what we did. We checked f of negative x to see if it would give me back the same thing, and it didn't, so it's not even. We checked negative x to see if it gave me back the exact opposite, and it didn't, so it's not odd. It has to be neither. Okay, now let's look at number 7. It says write g of x in terms of f of x after performing the given transformation of the graph of f of x. Okay, what I'm going to start with here is to make a table of values for both f of x and g of x and see if I can tell from the numbers what happened to my x values and or y values. So let's make a table of values for f of x. Based on what I can see right here, there's only 2 points really that I can look at. -2, 0. And 2, 0. And, oh, there's 3 points. 0, 2. Right? -2, 0, 2, 0, and 0, 2. For g of x, let's make that one in red, which is the closest I can get to that purple. So g of x, I'm going to make a table of values there. And I'm going to put them in the same order that I wrote the other ones, okay, even though it's not exactly in the perfect order. I see -4, 0. I see 4, 0. And I also see 0, 2. Okay, then you look at those numbers and try to figure out what happened to the x values, what happened to the y values. So first of all, I can see the y values, nothing happened, right? 0, 0, 2 is still 0, 0, 2. So let's think about our 4 parameters, b, h, a, and k. So let's recall, b and h affect the x values, a and k affect the y values. So since the y values have not been changed here, a and k have nothing to do with this transformation. It's b or h that have changed. Okay, so now let's look at the x values. Did I, remember b multiplies, h adds or subtracts. That's what it does, right? Did I add or subtract to these x values, or did I multiply these x values to get these new x values in the transformation? Okay. Now, you can say I added from -2 to -4, I subtracted 2, but that rule doesn't apply to the 2 and the 4, or the 0 and the 0, right? So it has to be a multiplication. So it's not h. It's a multiplication. What did I multiply these x values times to get these x values over here? And it should be pretty obvious that I multiplied them all times 2, right? -2 times 2 is -4. 2 times 2 is 4. 0 times 2 is 0. So I multiplied them times 2, and there's your answer basically. Almost, you're not done. B is equal to 2 because B is the one that you multiply. So since B equals 2, all I have to do is plug that in into my transformation, my basic transformation. So let's recall, if there's a function f of x, then the transformation of f of x is determined by this. A times f of 1 over b times the quantity x minus h plus k. Okay? So since I don't have to worry about a, h, or k, all I have to worry about is b, then my transformation just basically becomes this. F of 1 over b x. Right? Since there's no h in there, I don't have to worry about x minus h. There's no k, there's no a. So all I got to do is just plug in my b value into that function and I'm done. So g of x is equal to f of 1 over 2 x. And that's it. That is your transformation. Okay, number 8, multiple choice. Which equation matches the graph? Now in these multiple choice, there's a little typo right here, or a little mistake. For some reason, the number down here did not come out in the denominator. But it's okay, we can probably determine based on the h and the k values here. Okay, so let's see. I'm going to start by making a table of values with the 3 points that they have given me, which are 1, 2, 2, 1, and 3, 0. Identify from those 3 values your central point, your center point. Okay, it's very easy to see from the graph. You can also just see it right there. It's 2, 1. That center point, that is your h and your k. Okay, so h is 2, k is 1. The only question now is what are b and a. We are not going to worry about b, okay? It's a cubic function, so we're going to combine it together, and we're just going to worry about a in this case, okay? So b, h, a, and k, I need to know what a is. That's the only question I have left, okay? So if I write out my function, it should look like this. Y equals a times the quantity x minus h cubed plus k. So I already identified my h and my k, so I'm going to go ahead and plug those in. So it looks like this now. Y equals a times x minus 2 cubed plus 1. Next, I am going to use one of the other 2 points, either one, whichever one you like the best. I like this one the best because it has a 0 in it. Anything that has a 0 always makes your job so much easier. So we're going to use that point right there, 3, 0, and plug it in for x and y into your function, okay? And that way we're going to solve for a. So y equals a times the quantity x minus 2 cubed plus 1 becomes 0 equals a times the quantity x, which is 3 minus 2 cubed plus 1. I'm going to continue my work over here. So 3 minus 2 is 1. So 0 is equal to 1 to the third power, which is 1. So 1a plus 1. Subtract 1. And so negative 1 equals 1a, which means that a is equal to negative 1. All right. Now you got all 3 values that you need, and you're ready to write your function. Your final function is y equals a, negative 1, times the quantity x minus 2 cubed plus 1. And now I look at my options to see which one that looks like, and it looks like a, right? Negative 1 times x minus 2 cubed plus 1. That is the correct answer. Okay, number 9. Given this graph, write a function in intercept form for the given graph whose x-intercepts are integers. Assume that the constant factor a is either 1 or negative 1. Okay, so let's start by looking at the function and identifying the zeros. That's the first thing I'm going to do. Identify the zeros by looking at the function. I can see that one of the zeros is negative 1, another one is positive 2, and another one is positive 6. Okay, from the zeros, I move on to the factors. Which factors, there's 3 of them, because there's 3 zeros, give me those zeros, right? Think backwards. What equation did you solve to get negative 1? So you should see that it was x plus 1. And the next one is going to be x minus 2. And the next one is going to be x minus 6. And so that's my basic function. F of x is equal to that. The only thing I have left to figure out is what is the a value in here. And also, do any of these repeat? Meaning, do I have to put a square on any of these or not? Okay, so how do you determine the a value? The a value is determined by the end behavior. Okay, you look at the end behavior and you see, okay, is a positive or negative based on my end behavior table. So if you remember, a positive, a negative, and even, and odd would basically tell you what the end behavior is going to be. Just by looking at the graph, I can see that the end behavior is down and up. So by filling in my table, this is up and up, down and down, down and up and down. So it's this one, right? A is positive, N is odd. So A has to be positive. Now they've told me here, assume that A is either 1 or negative 1. Those are my only options. I'm not going to try to figure out if it's anything bigger than that. So it's either, my options only, is it positive or negative? The answer is A is positive. So A has to be 1. That's done. A is 1. Because the end behavior is down and up. So I can rewrite this function as f of x is equal to 1. Do I even have to write it? No. X plus 1 times the quantity x minus 2 times the quantity x minus 6. Next, what I need to figure out is, are they any of these squared or raised to a higher power? Okay, and the way you check that is by looking at the graph and see, does it cross or does it touch at those particular zeros? Okay, so right here at -1, does it touch or cross? It crosses. At +2, it crosses. At +6, it crosses. It crosses at all three of them, which means that the multiplicity of all three of them is odd, right? Even touches, odd crosses, ETOC. So since it doesn't touch anywhere, it crosses, the multiplicity is odd. So the multiplicity of 1 is fine. What if it had touched at any particular point? Then that means that the multiplicity is even, which means that I would have to raise one of these to the second power, okay? Because the multiplicity would have to be even, so to the second power would make sense. In this case, I don't have to. This is it. It crosses at each particular point, at each particular zero, so the multiplicity is odd, which means that that is my final function. Okay, now let's answer part B. It says use the graph to determine the number of turning points and the number and type, global or local, of any maximum or minimum values. Okay, I'm going to start with the turning points. That should be very easy to see for you guys now. Turning points, remember when the graph changes direction. So it's going up, then going down, or it's going down, then it goes back up. So I see 2. Right here I'm going up, and then I change direction. So right here is a turning point. And then I'm going down, and then I change direction. So right here is another turning point. Okay. So there are 2 turning points. Okay, the next is what are the types, how many and what are the types of maximums or minimum values? Maximums are bumps, minimums are dips, right? Bumps and dips is what you're looking for. There is one bump that I see, and there's one dip. This is a maximum, this is a minimum. The type is global or local. This one is going to be a local maximum. This one is going to be a local minimum. So one local max and one local min. And then are there any global max or min? And the answer to that is no, right? You can see that it keeps increasing and decreasing forever. So it will never reach a maximum, a global max or a global min. So there are no or 0 global max or min. And that's it. Okay, number 11. Given the function g of x is equal to the quantity x minus 1 times the quantity x plus 2 squared times the quantity x minus 6, we're going to answer a bunch of questions about this particular function. So first, find the power function that the graph of g resembles. All that question is asking you is, what is the parent function for this function? Okay, what's the power function that it resembles? So all you got to figure out is what degree is this function? Okay, so by looking at it, I can see that there's x squared, and another x. So all together, that's x to the 4th. This is a quartic function. Okay, the power function that it resembles is f of x equals x to the 4th. Okay. Next, determine the function's end behavior. The end behavior is determined by that table, right? Is it up and up, down and down, down and up and down, and so on. So this one, I can see that A is positive. How do I know that A is positive? Just by looking at each particular factor here. This one, the first value is positive, the first value is positive, the first value is positive. So positive times positive times positive is going to be positive, okay? So A is positive and N is even. Positive and even. Look at your table or memorize. You should have already memorized the table. Actually, let me draw it right here just to remind you guys. And even and odd. So positive and even means up and up. Positive and odd means down and up. Negative and even means down and down. Negative and odd means up and down. So in this one, we have positive A and even N. Positive, even is up and up. The end behavior is up and up. Okay. Now they want us to write it in this format. So here's what we're going to do. we're going to change this up and up to this format right here, okay? So what I want to do is, as x approaches, for x, you're always going to put both positive infinity and negative infinity, right? Which basically means as x goes to the right, what happens? And as x goes to the left, what happens? That's what these two are saying. As x goes to the right, what's happening? As x goes to the left, what's happening? Okay? So the end behavior is up and up. So on the left it goes up, on the right it goes up. Okay? So let's answer the question. As x goes to the right, what does y do? Does it go up or does it go down? So as x goes to the right, y is going up, right? So x approaches positive infinity, y also approaches positive infinity. As x goes to the left, that's what this means, negative infinity. As x goes this way, what's y doing? It's going up, right? So as x goes to the left, y goes up, or we can say as x approaches negative infinity, y approaches positive infinity. There. That's the end behavior. Next, find the x-intercepts. X-intercepts is the same as zeros, is the same as roots. So you're looking for the zeros, okay? Most of you guys are able to do that in your head now by just looking at the function, okay? If not, what you're looking at is these, right? Set each one of them equal to 0 to figure them out. So for example, if I want to do this one right here, I would say x minus 1 equals 0, which means that x equals 1. That's the first one. X plus 2 equals 0, which means that x equals negative 2. That's the next one. And x minus 6 equals 0, which means that x equals 6. That's the last one. There are 3 zeros. Determine whether each x-intercept is of odd or even multiplicity. You can tell that by looking at the original function and seeing how many times does each factor happen. This one happens once, so the multiplicity is odd. This one happens twice, so the multiplicity is even. This one happens only once, so the multiplicity is odd. So here's what I'm going to write. 1, odd. Negative 2, even. And 6, also odd. Each one has a different multiplicity, right? 1 is odd, negative 2 is even, 6 is odd. Now graph the function. How does that help us to graph the function? Well, if the multiplicity is odd, it crosses, right? Remember ET and the OC. Even touches, odd crosses. So if it's odd, it crosses. If it's even, it touches. So I'm going to plot those 3 points. 1, right there. Negative 2, right there. And 6, right there. I'm also going to use the end behavior, which is up and up. So on the left side, it's going to go up. On the right side is also going to go up. And use my information that here it's supposed to cross, here it's supposed to touch, and here it's supposed to cross. So it's going to go like this. At negative 2, it's only going to touch, right? So right here, it's going to touch only, not cross. So it's going to go down, just grace it and come back up. Then at 1, it's going to cross, so it's going to come back down and cross. And at 6, it's also going to cross, so it's going to go back up and cross. And that is your function. Right, part E, determine the number of turning points. So by looking at it, I can see 1, 2, 3. Right? It changes direction 3 times. 3 turning points. And finally, determine the number of maxima, local or global, and minima, local or global, if any exist. Okay, I see a local minimum, 2 local minimums, right? Right here, 1 and 2. Although this one is a global minimum because it's not going to keep going down. It's going to increase from this point on. Okay, this is a local maximum. Okay, so there is 2 local minimum. Now, some people believe that since it's a global minimum, you cannot call it a local minimum as well. Okay, I call it a local minimum as well because if I just look at that particular point of the graph, it is a local minimum. Okay, it's a dip. there are 2 local minimums or minima, 1 local maximum, right? 1 bump, 2 dips. Global, there are no global maxima, right? Notice that it keeps increasing forever. So there are no global max, but there is 1 global min, which is this one right here. It does not keep decreasing after this point. This particular point is the lowest that it gets, and then it keeps going back up. Okay, now let's look at number 12. Multiple choice. A classroom globe has a diameter of 19 inches. Which of the following is the approximate surface area in square inches of the globe? Expect at least 1 surface area problem. So go back and review those formulas once again, okay? Because you need to expect at least 1 surface area problem. In this case, we have a sphere. So the formula for the surface area of a sphere is 4 pi r squared. Right? So in this case, they're telling me that the diameter is 19 inches. Please don't use that as your r, right? We're looking for the radius, not the diameter. What we need is the radius. So the diameter is 19 inches. That is the distance from one edge to the other edge of my sphere, right? The radius is half of that distance. So the radius in this case is going to be half of 19, which is 9.5. Plug that in. And then after that, it's basically a punching into the calculator problem. Pi is 3.14 approximately, 9.5 squared, or you can just use the pi button on your calculator instead of 3.14 if you want to be more precise. So it's going to be 9.5 squared, gives me 90.25. Multiply that times 4 and multiply that times 3.14. And I get 1133.54 is what my calculator gets me. That's probably because of the rounding of pi. If I had used the pi button, I would probably get closer, but that looks like C. Let me double check that using the button for pi instead of 3.14. So 9.5 squared times 4 times, I'm going to use the pi button on my calculator, 1134.11. Yeah, perfect. That is the correct answer.